coordinated covalent bonds. A coordinated covalent bond is a bond in which both electrons are provided by one atom only. The other atom didn't contribute anything to that bond. That is called a covalent, a coordinated covalent bond. Let's look at the bond formation process for carbon monoxide to have a better understanding of the concept of coordinated covalent bond. So we have a carbon atom which has 4 valence electrons, an oxygen that has 6 valence electrons. Neither of the two is happy by itself because they do not have 8. Now one day they come across each other, they look at each other, they realize that they are both nonmetals, they cannot fight, they start sharing. Oxygen offered 1, carbon offered 1, a pair of electrons shared. Now carbon has 5 around it, oxygen got 7. Neither is happy, continue to share. So take 1 electron, carbon, put in the middle, oxygen take 1, put in the middle, a double bond is formed. Let's rewrite the bonding situation now. Carbon still has 2 electrons around it, but there's a double bond between carbon and oxygen has 4 electrons around it that are not bonded. If you look at the total electrons, total valence electrons around each atom right now, carbon got 6, oxygen got 8. All right, oxygen said, okay, I'm all set, I'm done, I'm happy. Well, carbon is not happy. Carbon saying that, you know what, you got 8, but I got only 6. Well, oxygen realized that as well. Okay, oxygen take a pair of electrons from itself, put it in between the carbon and oxygen. By doing this, this is a very unselfish behavior. So by doing this, both carbon and oxygen are happy now. Carbon got 8, oxygen gets 8. The last pair of electrons being put in between the carbon and oxygen is totally from oxygen. Carbon didn't contribute anything. That bond is a coordinate covalent bond. However, once a coordinate covalent bond is formed, it is indistinguishable from other covalent bonds, which means among the triple bonds here, all you know is that one of the 3 is a coordinate covalent bond. However, the 3 pairs behave identically. You cannot distinguish which pair is actually the coordinate covalent bond. Let's look at another example, a comparison between hypochlorous acid and chlorous acid. In the hypochlorous acid, all the bonds are regular. The single bond between oxygen and hydrogen, a single bond between oxygen and chlorine, they're both regular covalent bond. But if you look at chlorous acid, the last bond between the oxygen and the chlorine, both electrons are actually from chlorine. The 6 valence electrons that oxygen has are still on oxygen atom. So this pair of electrons is actually contributed by chlorine only. That is a coordinate covalent bond. Well, there's one thing that can help you to identify if a bond, if there is a coordinate covalent bond involved or not. If there is a coordinate covalent bond around the atom, then that atom doesn't have their normal number of covalent bonds. For example, oxygen, we realized that last time that oxygen normally forms 2 bonds Look at here. In this chlorous acid, oxygen has only one bond. That is a strong indication that there is a coordinate bond around oxygen. Chlorine is in column number 7A. Normally it forms one bond only. Now it has one bond here, one bond here. It has two bonds. Again, a strong indication that chlorine, those two bonds, one of them is a coordinate covalent bond. Combined with the situation of oxygen, we know that it must be the bond between chlorine and oxygen that is the coordinate covalent bond. Once a coordinate covalent bond forms, it is indistinguishable from other covalent bonds in the molecule. We discussed that. Good. This picture shows us the comparison between the formation of a regular covalent bond and a coordinate covalent bond. So for a regular covalent bond, each atom provides one electron to share. That's a regular one. In the coordinate covalent bond, one atom offers both electrons. The other atom only offers an empty orbital. They overlap to form a coordinate covalent bond. Oh, just talked about this. Again, if an atom doesn't have the normal number of bonds it will form, that is an indication of the presence of a coordinate covalent bond. And again, a coordinate covalent bond is indistinguishable from regular chemical bond. Practice. For this molecule, the concept of a coordinate covalent bond is needed to explain the bonding between the two nitrogen oxygen, both of them. Oh, okay. The question is asking you, is there a coordinate bond here? Or is there a coordinate bond here? Or is there one for each of the two? So those are the three answers. Well, let's look at the nitrogen. Nitrogen is in column number 5A. It will form three bonds. So this first nitrogen does have three bonds. That tells you this bond is actually normal. Right away, that tells you this triple bond, they're normal covalent bonds. This nitrogen, the second nitrogen here, again, it normally forms three bonds. Right now, it has four. All right, looks like there is a coordinate covalent bond around that nitrogen. Well, if those three are regular bonds, then that one likely will be the coordinate covalent bond. Let's verify this with the situation of oxygen. Oxygen normally needs two bonds. Right now, it has only one. Yep, there is a coordinate covalent bond around the oxygen that tells you this is the answer. The bond between the nitrogen and oxygen is a coordinate covalent bond. In which of the following molecules is a coordinate covalent bond present? Okay, follow the procedure we just used for the question number 1. So look at how many bonds each of the atoms involved is going to normally is going to form, and check if it does have that number of bonds or not. If it does, they're regular bonds. If it doesn't, there should be a coordinate covalent bond. Check, use the same procedure for all three molecules. So there are 1, 2, 3, 4, 5 possible answers. Okay, choose one, any one of them, or choose all of them, or none of them. Pause the video, come back for the answer key. Here is the answer key. None of them has coordinate covalent bonds. All the bonds involved in those three molecules are regular covalent bonds. See you next time.